these last few lessons, we've been talking about greatest common factor, least common multiple, and how we can use those in different situations. Well, today we're going to be looking at how we can use greatest common factor in a real life situation. So we're going to start by looking at our problem. So it says a trophy case at Riverside Middle School holds 18 baseball trophies and 24 soccer trophies. All shelves hold the same number of trophies. Only one sport is represented on each shelf. What is the greatest number of trophies that can be on each shelf? How many shelves are there for each sport? And then it says use the graphic organizer to help you solve the problem. So, it's really important. I know there's a lot of words in there. It's really, it can be overwhelming, it can be frustrating. The important thing is you want to make sure you're reading these word problems more than once so you really know what it's asking. Especially this word problem because it has two questions that we need to answer. So I'm going to read it quickly one more time. Follow along with me. A trophy case at Riverside Middle School holds 18 baseball trophies and 24 soccer trophies. All shelves hold the same number of trophies. Only one sport is represented on each shelf. What is the greatest number of trophies that can be on each shelf? How many shelves are there for each sport? Now, this word, greatest. That right there is a very important word because it tells us we are going to be finding greatest common factor of our numbers. And we have two numbers here. We're dealing with 18 baseball trophies and 24 soccer trophies. And the question that we are trying to answer, the two questions we're trying to answer, are the greatest number of trophies on each shelf and how many shelves are there for each sport, okay? That's really the important parts of this word problem. The rest of it, you really don't need to worry about all that much. Just what are our numbers that we're dealing with? We have this word greatest, which tells us we're dealing with the greatest common factor, and then the two questions we have to answer. The greatest number of trophies that we can have on each shelf, and how many shelves are we going to have? So if you look down below this problem, I gotta clear off my board real quick. You'll notice that they have some stuff here already for us. So I'm going to scroll down so we can see everything that I'm looking at. So, and I would like you to please fill this in with me because this will be something you can use to look back at when you're doing your lesson check, when you're doing your personal math trainer. Please fill this in with me. So, for what do we need to find? Well, if you wanted to look back up at the problem, you could, but we need to find the greatest number of trophies on each shelf and remember there were two questions that we have to answer, and number of shelves for each sport. Run out of room. Okay, that's what we're trying to find. The greatest number of trophies on each shelf and the number of shelves for each sport. What information are we using? We are using the given number of trophies for each sport. And down here at the bottom, this bottom box is really one of the most important. How are we going to use this information? First, we are going to find the GCF, the greatest common factor, of 18 and 24. And we're going to use it to draw a diagram representing the shelves of the trophy case, which they have already started here for us. Okay? Now we're going to get into the work. So, the total trophies is equal to the number of baseball trophies plus the number of soccer trophies. And it's these words in blue are really going to help us with how to go about solving this problem. First step, find the GCF of 18 and 24. So find a space where you have some room, maybe up here, so we can write out the factors for 18 and 24. Well, we have 1 and 18. We have 2 and 9. We have 3 and 6. Nothing times 4, nothing times 5, nothing times 7. Okay, for 24, we have 1 and 24. We have 2 and 12. We have 3 times 8. And we have 4 times 6. Those are our factors. Now, let's look for the greatest common factor. We can circle our factors here. We have 1, we have 2, we have 3, we have 6, and that's it. So our greatest common factor is 6. Now, here's where you might get a little bit confused because they want us to write each number as the product of the GCF and another factor. This is what we did on Friday, where we're using this distributive property. So it breaks it down nicely for us because it says 6 times what is 18? 6 times 3 is 18. 6 times what is 24? 6 times 4. Now here's where the distributive property is going to come into play. They pull the 6 out from both of those pieces, so that goes on the outside. So now we have 6 times 3 plus 6 times 4. So that means we are going to have 3 rows of baseball trophies with 6 in each row, because 3 times 6 is 18. And we're going to have 4 rows of soccer trophies, 6 in each row, because 6 times 4 is 24. So if you want to, you can go ahead and fill this chart in the rest of the way. Okay, I'm not going to continue filling that in just so we can save a little bit of time. But that is another way that you can look and see the visual representation of how to solve this problem. So now I am going to clear this off because I need to scroll up a little bit so we can see the bottom. This is the important part. So there are blank trophies on each shelf. So we're answering the question here. What is the greatest number of trophies that can go on each shelf? Think, what was the greatest common factor? 6. 6 trophies are going on each shelf. There are 3 shelves of baseball cards because there were 18 total trophies. Because there were 18 total baseball trophies. 3 times 6 gives us 18. And there are going to be 4 shelves of the soccer trophies because 6 times 4 gives us 24. So that was our first problem. Now let's look at another one. We're going to just scroll. I'm going to scroll right on down, and you just need to flip to page 30 now to the try another problem. So Delia is bagging 24 onion bagels and 16 plain bagels for her bakery customers. Each bag will hold only one type of bagel, Each bag will hold the same number of bagels. What is the greatest number of bagels she can put in each bag? And how many bags of each type of bagel will there be? All right, one more time, I'm gonna read it. Delia is bagging 24 onion bagels and 16 plain bagels for her bakery customers. Each bag will hold only one type of bagel. Each bag will hold the same number of bagels. What is the greatest number of bagels she can put in each bag? How many bags of each type of bagel will there be? So, we're going to do this exactly like we just did the last problem. Let me just clear off my circle there. So what do we need to find? Let's fill this in. We'll fill in our boxes over here, and then we'll solve the problem. So we need to find the greatest number of bagels she can put in each bag and, remember there are two questions, and the number of bags of each type of bagel. Okay, kind of a lot, but remember we have two questions that we're answering. And when you have your final answer, you always want to go back to your question and make sure you answered the entire question, okay? What information are we going to use? So we're going to use the fact that there are 24 onion bagels and there are 16 plain bagels. That's the information that we have. And how are we going to use it? We will find the GCF. So you can say, I will find GCF of 24 and 16. But that's not all we're doing. And use it to, oops, I deleted some of my letter there, and use it to draw a diagram where we will find our answer. I'll give you 1 second to finish copying there because that's kind of a lot to write. So, up here at the top, this is our space where we're going to use to solve the problem. We have our total bagels. Please write everything I'm writing. Equals our 24 onion plus 16 plain. Okay? Now, first step is to find the GCF, greatest common factor. So let's take 24 and let's take 16 and list out those factors. 1, 24, 2 and 12, 3 times 8, 4 times 6. For 16, we have 1 and 16. We have 2 and 8. Nothing times 3, we have 4 and 4. Nothing times 5, nothing times 6. So, common factors, 1, 2, 4, and 8. So our GCF is 8. That is important. Very important to remember. So I'm going to copy the addition problem down here again, 24 plus 16, just so we can use this for a reference. Now we are going to start using that distributive property. So we can break 24 down into 8 times 3, and then our plus sign in between. 16 we can break down, has to be something times 8, because we said that is our GCF, 8 times 2. Okay, now we're going to pull those 8s out. They're going to come to the outside. 8 times 3, that's all that's left, plus 2. So now, to answer the question, there are going to be 8 total bags, and there will be 3 bags of onion bagels, 2 bags of plain bagels. And we can draw this out using a diagram. So we have to have, starting with our onion bagels, we'll do O's for onions. There are going to be 3 bags of them. We'll do O's. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. There are onion bagels. 8 bagels into 3 bags, which gives us 24 total bagels. Now, we have 16 plain bagels. Once again, there are going to be 8 in each bag, but now we're only going to have 2 bags of the plain. So peas, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. To make up the 16 plain bagels. I'll give you a second to copy this down, because down below this is where we really need to put our answer, our numbers in to answer the question so it makes sense.